Right, BGP path is based on the attribute. The protocol BGP is the only one which has got the flexible, very high rich metric called attributes. In that we learned that some attributes are popular among all vendors. They are called as well-known. In that well-known, some attributes are mandatorily need to be seen in the update. If it is not seen, then update is considered as invalid update. Such attributes are called as well-known mandatory. But there are some well-known attributes which are not mandatory. If it is seen, good. If it is not seen, also okay. Those are called as well-known discretionary. Now, there is also another attribute called optional, which means they are not well-known. They are seen in some vendors only. So such attributes, when Cisco receives the packet with such optional attribute, if it will accept that packet, then it is optional transitive. If it will reject the packet, if you don't see this optional attribute, then it is optional non-transitive, because if you don't see, it won't accept the packet. Even though it is optional, it is mandated for Cisco to see. That is optional non-transitive. If it is not seen, it won't send. But some optional attributes, even though if it is not seen, it is marked as partial and it is used. They're optional transitive. So those differences in definition, you can see it here. As I said, well-known means what? Must be recognized. Must be recognized. It is seen in all vendor. Only if it is mandatory, it is must be present. If it is maybe, then it is well-known discretionary. Even though it is recognized, it need not to be present if it is well-known discretionary. Recognized by all vendor, meaning every vendor will know, yeah, but we know what it is. We know what it is. But not everyone will consider it. Such attributes are well-known discretionary. Now, optional attribute, as I said, some only knows about this attribute. So now, if it is not recognized, it is still accepted as partial update and propagated to other neighbor. Those are optional transitive because it is propagating, transitive. If it discards when it is not recognized, then it is optional, non-transitive. Some of the attributes, yes, sir. Yeah, correct. Now you are receiving a packet, BGP update, not packet. You are receiving a BGP packet. It's an update. I'm talking about. We are not talking about the packets, user packets. It is the update. When an update comes, if that is the update with the attribute which is not popular, it is not popular attribute. It is not known to everyone. Then it is optional. And if that optional attribute is not seen, even though it is not seen, you mark it as partial, meaning you accept it. Even though it is not seen, you accept it by marking it as partial. Then it is optional transitive. When you don't accept it, when you discard it, even though it is an optional one, I want to see, otherwise I will not accept. Even though it is not popular, I still want it. Otherwise I will not accept it. Then, yeah. Correct. Single BGP update will have many attributes, but it is checked in a sequence. In that sequence, if the first one is met, if the first one is a tiebreaker, it won't read the other attributes. All will be there, but all are not used. When there is a tie in the first one, sorry, when there is a tie, it will go to the next one. When there is a tie break in the first one, it won't go to the second one. We have attribute list, 11 attributes. We'll see that later in the next chapter. So we have seen the classification of attributes. Now here are some attributes. Example, AS path, origin, next hop. These three, they are well known. Even local preference is well known. MED is well known. All these attributes are well known. But in this, mandatory is AS path, next hop, and origin. See, if an update comes to me without MED configured, I accept it. Without local preference configured, I accept it. But I will not accept a packet which comes without origin. I'll not accept a packet that comes without next hop or AS path. See, because they are not only popular among all vendors, they are also mandated for every vendor. Without that update, BGP packets cannot be received. BGP updates cannot be received, accepted. Okay. Now the first one, MED stands for multi-exit discriminator. We'll understand what it means in the coming slides. About all this one by one we are going to learn now. We are going to first learn AS path. See in the next page. So MED is going to come later in this chapter. All right. See, AS stands for autonomous system path. When a BGP update is received for some network, it is not only going to send you the network info, along with that it will attach a lot of attributes. One of the attribute is the autonomous systems in the path. When you receive an update, you can very clearly say that from where this originated, where this update originated, and what are all the autonomous system through which this update has reached you. See, in the internet, there are many autonomous systems. You may receive an update from Australia. From Australia to India, it's not one autonomous system. There may be 10, 20 autonomous systems in the path. So it will clearly show the path, autonomous system path, when you receive the update. In India router, you can see the destination of Australia network is like 10 hop away, 10 autonomous system away. That is why BGP is called as path vector routing protocol. Path vector routing protocol. Now, if you see this example here, router B is learning a network from router A. What is the network of router A? 192.168.1.0. If you notice, there are three autonomous systems. B don't have any direct connection to autonomous system A. It receives the updates via autonomous system C. So when 192.168.1.0 received on router B, it will show the path 65.500, which is autonomous system C, the immediate autonomous system, and 64.520, which is the originator of this update. See, the first autonomous system is the immediate autonomous system number. When this is received, 192.168, when this is received, the first number is the immediate autonomous system. The next number is the next autonomous system, and the last number is the original source from where it is originated. So it shows the autonomous system path, and this is known as AS path attribute. And this attribute, if it is missing in any update, it is not possible in first place. If it is missing, then the receiving router won't accept it. Without this information, if C tries to give to B, B won't accept it. The AS path attribute is mandatory. Without AS path info, it won't accept. Right? So from where this is coming matters. It's well-known mandatory. AS path is a well-known mandatory. Let's go to the next one. Next is the next hop. Next hop is also one of the important attribute. You should get a next hop address. If you don't have next hop address, then it cannot be a valid update. About the next hop, we already learned many things. You remember, eBGP address is carried into iBGP. And that is what explained in the two paragraphs. Router A is advertising 172.16.0.0 with a next hop of 10.10.10.3. When router B advertises the same, it will keep that same 10.10.10.3. So this is well-known attribute called next hop, and it is also mandatory. Without next hop address, no BGP updates are valid. Yep. So that's about the next hop attribute. Next is origin. See, origin tells you how the network is originated. No. That is the AS number, autonomous system number, from where it is originated. It is not talking how it is originated. It is simply saying which autonomous system is the originator. That won't come under origin. That may be a AS origin of the AS, but that will not be considered as origin. Now, what is origin attribute? Origin attribute will tell the other autonomous systems of how the prefix were introduced into BGP. You see that line? In that paragraph, second line, you see how the prefixes are introduced. It is talking about how, not where. It is talking about how. You see, you can introduce network in two ways. One by advertising, the other one by redistribution. Do you agree? Hmm. If you advertise, then the other autonomous system will know that it is advertised. If it is redistributed, other autonomous system will know that it is redistributed. How? This attribute will attach. When I advertise, I will be attached to the update. You see there, first one, I, small I, IGP, the bracket I is there, no? That I will get attached when I advertise. See, what is the command we use to advertise? Please understand my question. What is the command you use to advertise a network? Ah, whenever you advertise a network using network command, that network will advertise with I attribute. Instead of advertising, if you redistribute, then it will have question mark. You see the third one there, question mark, incomplete. Redistribute from IGP or static node. What is this IGP? This IGP can be EIGRP or OSPF or RIP, or it can also be a static node. Now, if I redistribute, those networks will be advertised with question. If I advertise, then those will be advertised with I. Now, what is the second one called E? Small e in the bracket. You see EGP? Do you see that in the page? EGP, small e in the bracket. Once upon a time, we had a protocol called EGP, which was like BGP, but there was a lot of problem with that protocol. It was not really that effective like BGP. So it got, so instead of using EBGP, people used to have EGP. And then from there, they used to redistribute into IBGP. Later, it is slowly removed. EGP is no more, so don't worry about that protocol. Now, whenever a network is advertised, it is always going to have either I or question mark. In Australia, someone is advertising. In India, I'll receive it with I or question mark. If I receive it I, then I can understand that in Australia they used network command to advertise. If I see question mark, what does that mean? They did redistribute from OSPF or static hook. Isn't it? Okay. So this is also a well-known attribute and mandatory attribute. Networks, other autonomous system. You see the line? The origin attribute informs all autonomous systems. That is why I say in Australia it is advertised. It is informed to every autonomous system in between Australia and India. And when I receive in India, I can see all the prefix with I or question mark. This is a mandatory one. Well-known and mandatory attribute. So far, what we have seen is AS path attribute, and then next hop attribute, and now origin. This is well-known mandatory. The previous two also well-known mandatory. Okay, is next hop well-known mandatory? Okay, is the AS path? Okay, origin is also well-known mandatory. Now what is coming next is well-known but not mandatory. Well-known discrete, which is coming next, and the attribute name is local preference. See, local preference. Now, before going to local preference, which is well-known in discrete, let's see this output which they have shown here. What do you understand from here? Check those three attributes that you learned. Well-known mandatory attributes. Do you see them for all networks, all prefixes? These prefixes are learned from, this one is learned from, this is the originator. This and these are two autonomous systems from where this network is learned. So there is path vector. Next is, do we have next hop? Yes. If the network is on the same router, then you will have 0, 0, 0, 0. If this network is on the same router, you'll have 0, 0, 0. This network is also on the same router. And origin, you see, I. What does that I means? It is advertised, not redistributed. If it is question mark, then it is redistributed. Yeah? Okay. Sorry? This is the autonomous system number. So the command to see this output is show IP BGP. With the command show IP BGP, you will see both advertising network and learned network. What you advertise will have next hop 0000. Whatever that you learn from others will have some address as the next hop. And whatever you advertise, the weight will be 32768. Do you see that? If the next hop is 0000, the weight is 32768. Weight is an optional attribute. Weight is optional. We'll see weight later. I'm just telling you here, if you see next hop 000, weight will also be 32768 by default in Cisco. Weight is a Cisco attribute. You cannot expect this in other vendor. This attribute, that is why it is optional. Other vendors are, what is optional attribute? It is not popular. Weight is not popular. It is only in Cisco. Right. Now, what is the next attribute? Do you see that in the output here? Yes. You don't see for some. Yeah. For few, you don't see local preference. Yeah. Which means it is not mandatory. Which means it is discrete. Well-known discrete. Now, let us read this. What is weight attribute? And you saw 100 because that is default there. Is everywhere. Sorry. You see, oh no. The default value is 100. That's why you saw in the previous page 100. You saw no 100. Did you see any other number for local preference? No. But you can set some higher number or lower number. Now, what is the meaning of that? You see, for router C, I'll call it a C here. Router C can go like this to this network. It can also go like this to this network. Yeah. Now, if you want all the routers, if you want all the routers in this autonomous system, not one or two router, all routers. If you want all the routers to go out, exit via router A. Router A is also your router only. Instead of going via B, you want everyone to go out via A. That is your expectation, your policy. Then you go to A only and set local preference higher than B. B is 100 by default, but you have set 150. It's okay. It should be more than 150 on A. Now, as soon as you set 200 and 150, you no need to inform C. You no need to inform C. You no need to inform C because local preference is advertised to all what neighbors? It will be advertised. It will be informed to all IBGP neighbors that A has got more local preference. A has got 200. So every router will now only go via A. See how the attributes can be used to decide the path. You don't need to go and do anything on router C to achieve this. Just go to A and give high local preference higher than B. Automatically every router's inside, like a C router, every other router will exit via A. Yeah? Do you have any question on local preference? Do you have any question on local preference? Read, read, read. Read to yourself the 4 lines here. Okay. The next attribute is MAD. See, this one which you saw now is well known but not mandatory. Well known, discretionary. Likewise, you have another well known discretionary which is MAD. Yeah, multi exit discriminator. Now, you see, for this network, B is advertising MAD 150. C is advertising MAD 200. If it is weight, bigger is preferred in weight, whereas in MAD, lowest is preferred. So now A will enter into 65,500 via B. It won't enter via C. Why? A will prefer the lowest one. If I go via B, how much? 150. If I go via C, 200. Now, tell me, what is the difference between this one and the previous one? Very good. 1 point. Very good. This is between eBGP, that is between IBGP. Second point. That one was telling how to leave. No. Okay, good. That is another one. MAD lower is preferred. Local preference higher is preferred. Correct. Now, that one was telling how to leave the autonomous system. This is telling how to enter the autonomous system. Yeah. Where the traffic should enter. If the traffic should enter via B, then give more or less number. traffic will enter via B because it is less number. You understand? All right. Weight is a Cisco proprietary attribute. Weight is an optional attribute. See, this is same like AS part. Sorry, this is same like local preference, but the difference is local preference is for all the routers, right? When you set on one router, it is advertised to all the routers in IBGP. Correct. Sorry. The default weight is 0, but if you go to A and give more weightage to B, then traffic will go this way. See, local preference and weight, what is the difference? Weight is only on the router where you configure this. It is not applicable for other routers. It is not applicable for K and J. Whereas if this is attribute instead of weight, then everyone will know that A has got 200. You understand? Now read this line. Weight is not sent to any BGP neighbor, neither to eBGP nor to IBGP. It's local to this router only. Now for local origin, locally, advertised network, what is the weight? It is not 0. It is 32768. But for the networks coming from other routers, it is 0. You saw that in the output, right? Okay. So we are going to get into something important. I think we should stop here.